So, what up? This is Mr. Pagan, and this title is called What is Geometry? So, what is geometry, you ask? Well, technically, it's the visual study of shapes, sizes, patterns, and positions. Now, geometry is a different type of mathematics. When we look at it, we have to look at a shape, dissect the information, apply what we know about algebra and all this other good stuff in math, and figure it out. Now, it's a little different now, but you'll get used to it and you'll do great. Trust me. But before we get started with learning the actual geometry content, we have to know what we're talking about. So today is packed with a lot of vocab and notations and things we need to be comfortable with before moving forward. So we're going to look at some terms, how that term looks in a diagram, and then lastly, how we name that term with correct notation. Alright, so the first one we're going to start with is a point. Now, a point is exactly what you think it is. It's simply a dot or a point that we use in diagrams typically to represent intersections or points on lines, things of that nature, and it's always named with a capital letter. So to name this point, we would simply call it point P with the capital P. Alright, the second thing we have is called a line. Now, a line is exactly what you think it is. It's a line. What's unique about a line is it has arrows at either ends, which means that it goes on forever in both directions. It never stops. Okay. Now, how we name a line is simply with 2 points. So I could call this AB. I could call this BA. The order of the points actually does not matter. I could call it any 2 points. So line AC, line CA, line BC. Any of the points on that line. Sometimes also they have a little script letter, and I could call this line L. That's another appropriate way to name a line. Okay, now within a line there's some other types of things. The next thing we have is a line segment. Now, a line segment is a line that has a beginning and an end. It has 2 endpoints where the line officially starts and where the line officially ends. Okay, we call that a segment. So I would call this segment AB, line segment BA. Again, the order does not matter, but the notation is very important because the notation tells us what we're dealing with. Okay, and then the last thing we got is what we call a ray. Now a ray is kind of like if a line and a line segment came together and had a baby. Alright? One side is an endpoint and it extends forever in the other direction. So let's say we call this ray CD. Now the notation is very important. Here the C actually has to come first. The end point always comes first and the arrow points in the other direction. So again, your end point always has to come first when naming a ray. Alright, so those are kind of the lines that we deal with. Next, we have what we call plane. Snakes on a plane. Alright, so a plane is simply a flat surface. Now, in order to define a plane, we need 3 points on that plane, 3 non-collinear points. Okay, non-collinear simply means that they are not lying on the same line. So I would simply name this plane ABC, naming all 3 non-collinear points. Now I could also call this plane CAB. That would also be appropriate. Sometimes, again, similar to a line, they'll have a script letter here. I put an M, so you may call this plane M. Alright, so that's a plane. Now lastly we have an angle. And I'm sure you heard of this one before, but maybe you never seen it. So an angle looks something like this. An angle is made of 2 rays. Alright, notice BA is 1 ray, BC is another ray, and they're connected at a point which creates an angle. Now, where those 2 connect is what we call the vertex. And that's a very, very, very important point right here, the vertex. Because when we name an angle, the vertex has to be in the middle. So for instance, angle ABC or angle CBA or simply just angle B. Now, we're allowed to call it angle B because there's only one vertex. If there was more than one vertex, we wouldn't be able to do this. For instance, if it looked like this. Okay, we could not call this angle B because an angle exists here and an angle also exists on this side. So it would not be specific enough to call angle B. Okay, we would need to call it ABC or ABD to specifically identify that angle. Alright, so those are kind of our main things. Point, line, there's three types of lines: a regular line, a line segment, and a line ray. A plane, which is a flat surface that contains three non-collinear points. And an angle, make sure you know what the vertex is, because the vertex always has to be in the middle. When naming an angle, we go in order. Alright, good. A little bit more vocab for you. Now, I talked about three non-collinear points being on a plane, and I said non-collinear means they don't lie on the same line. So what do you think collinear means? Well, if non-collinear means they don't lie on the same line, collinear means points lying in a straight line. So if 3 points lie on a line, it's said to be collinear. So we could say points A, B, and C are collinear. They all lie on the same line. Coplanar is exactly what you think. If collinear is they all lie on the same line, coplanar is a number of points lying in the same plane. Alright, it's collinear, coplanar. When we say that, make sure you know what it means. Okay, again, if I'm moving too fast, please pause it, copy the words, and then hit play again and move forward. Okay, lastly, we're going to talk about intersections. Intersections. Now, I'm not the best artist, so just bear with me, and my pictures will make sense. Alright, the first thing we're going to talk about is the intersection of two lines. Alright, so if we have two lines intersecting or crossing, we say two lines intersect at a point. So two lines intersect at a point. Now, how would I name these? Let's call this line K, call this line L, and this point R. So how I'd write this, or how I would say it, is line K and line L intersect at point R. Line K and line L intersect at point R. Pretty self-explanatory. What if I have a line and a plane? What would the intersection of a line and a plane look like? Well, let's actually start with the plane. So we know a plane is a flat surface. Now, a line and a plane actually intersect at a point. So for instance, if I have a line here, alright, let's call this plane M, we'll call this line T, and they intersect at point R again. Okay, so think of if I had like a piece of paper and I punched a pencil through it. Okay, where the pencil poked a hole in the paper, if we held the pencil there, that would be my intersection point. So this dashed or dotted line here is that piece of the line behind the paper that you really can't see. Alright, so think of punching a hole in a piece of paper. So a line and a plane also intersect at a point. Okay, so I would say line T intersects plane M at point R. Line T intersects plane M at point R. Alright, and lastly, what if we have a plane intersecting another plane? Alright, now, So here's one plane. Alright. So let's call this plane M again. And this is another plane, plane N. So plane M and plane N. Now these two intersect at a line L. So two planes intersect at a line. Now think of this. Think of if you had two pieces of paper and you put the edges together. Okay? So one piece of paper would be one plane, the other piece of paper would be the other plane, and if you were to tape them exactly together, you would tape them on the edge of the paper. Right? So this would be the edge of the paper here. Alright? That edge of the paper where they connect, where you would put the tape, would create a line if it went on forever. Alright? So that's kind of how I drew that to visualize that. Alright, so those are three intersections we're going to focus on. Two lines intersect at a point, a line and a plane intersect at a point, and two planes intersect at a line. Well, that's all I got for you today. Thanks.